Think with me through the questions. They'll be on YouTube later, or right away, right after class. So, so they're asking. It's off the screen, but they say in the. Let me write it more clearly. In the interval, come on. In the interval minus 2, 0, is f strictly decreasing? What are they talking about? Well, first off, when you look at minus 2, 0, let me help you with notation. Math's notation can be a little confusing in this situation. When you look at minus 2, 0, you might think, is that like an x value and a y value? Is that like back 2, up 0? Is that what they mean? Or do they mean like all the numbers on the x-axis from -2 to 0, like everything in that region? Yeah, that's what they mean. How do you know? Well, actually, this could mean either one. Be better if math came up with a different notation for points than they did for intervals, but they didn't and we're stuck. So that could mean an interval or a point. How do you know which one then? Context. It's like when you read, certain words can mean different things, but what rules is context. See what they said there? Interval. They said it's an interval, so it's not a point. It's an interval, which means these are both x values. It's from x -2 to x 0. It's this chunk on the x-axis. Do you see that? It's not a point. It's an interval. So they're saying from here to, whoops, that's too far. From here to here, right? This is the chunk of the graph that goes from x -2 to x 0. That's what they're really saying. I think once you know what the question is, the answer is easy. Once you're speaking their language, you know. They're saying that chunk of the graph right there, is it going down? Well, yeah, easy question. They would just speak English, huh? Yeah. So yeah, it's going down. That's what you mean. So they mean that interval. That's the whole question. You ready for another one? So it's all about knowing. So again, this notation can mean point or interval. It's just context. We'll tell you, they said interval. Interval means x-axis only. They're saying list the x values where it has a local max. A local max. What are they talking about? Well, right here's a max, and right here's a max. We call those local max because we don't know. The function might just go up, 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 even higher later. You know, there might be a higher maximum some other place. I don't know. Probably not. Looks like it just keeps going. It's a sine curve or something. Keeps going up and down. But whatever. I just know that this guy is a maximum in his little vicinity, in his locality. We call him a local max. And this one is a local max, right? Okay, so what's that x value there? Is it 4? It looks like it's 4. Yeah, 4. That's x value 4. Just look at the graph. This one, what's that one? Is it -12? Yeah. So that's x equal, they want you to go 4. They just put a comma between them, either order. Doesn't matter. They just want the x values where there's local max. So, okay, so on this graph right here, they're saying, part C I think it is, list the intervals. This is the only new part. The other parts you already know. List the intervals where it's increasing. Now, increasing means right there it's going up, right there it's going up, right? Increasing, now you might wonder, maybe I should address that for a second. You might say, well, how do you know those are the only increasing pieces? I mean, if I'm on the mountain here and I'm going that way, I'm increasing. I'm going up. Why don't we call that an increasing section? And what's the answer to that? We never go left. We just always mean as you're going to the right. That's simply the answer. Because otherwise, we wouldn't be able to distinguish at all, right? Yeah, any mountain, it's like saying, does that mountain go up or down? Well, mountains do both. Depends which way you're on it, right? So anyway, so that's the point. So what do we mean by an increasing piece? We always mean as you go to the right. So as you go to the right, this first piece is decreasing. Then this is increasing, decreasing, increasing as you go to the right. We always mean as you go to the right. So, okay, so as you go to the right then these are the only two increasing pieces. But they want interval. Remember what interval means? X and X. Like like a left and a right. They want a left and a right on the x. X left, x right. That's what an interval means, like a domain. Left edge, right edge on the x-axis. That's what an interval is. Left and right edge on the x-axis. So this goes from -1 to 0 on the x-axis. This one goes from 1 to what, 3? On this. So -1 to 0 and 1 to 3.
Would you use a unity in the answer?
What's that?
Would you use a unity or just a...
Yeah, and they changed their mind, I think. I think they just want commas. -1 to 0, 1 to 3. I think they just want it with comma. I'll go back and look. Everybody see that? Now, you might want, here's what would kind of bug me. I would be like, wait a minute, sir, shouldn't we have brackets on those? I mean, because those are straight on the edges there. Shouldn't those be brackets? Well, honestly, on a test, I don't care. I think it's all kind of a dumb question. It's the same thing either way in my mind. I'm not going to test you on that such a silly little thing like that. But yeah, so just know they want parentheses because, I mean, I guess technically, they're right if you get super picky. Right at -1, I mean, right at that dot, you're not going up or down because you're at one dot, right? So yeah, technically it's only between the edges that you're really rising. Okay, yeah, they're being super picky. I wouldn't care. If you said -1, 0 on a test, I would be fine. You got the idea. It doesn't, I don't think it really matters. But anyway, just letting you know, they want parentheses on these interval answers. I want to let you know so you don't, because these are like 7 parts. You don't want to get like one part wrong and they have to redo the whole thing because of parentheses and brackets. So they want parentheses. Whenever they say intervals, increasing, decreasing, they want parentheses. They don't want the edges included because you're still at an edge. You're not going up or down. Odd, let me give you a hint. Well, let me start with even. Even, the word even comes from like even powers. What does y equals x squared look like? What's a graph of y equals x squared? Yeah, you all aware it's a U shape? It's a parabola. It's a U shape. Okay, and y equals x squared, the parabola y equals x squared. What kind of symmetry does it have? What kind of symmetry? Like what's a line that it's the same on both sides of? Y, it's got y-axis. It's the same both sides of the y-axis. Y-axis is like a mirror. Even functions have y-axis symmetry. It's just another way to say y-axis symmetry. When you say even, it's another way to say y-axis symmetry. So you can put that in your 3x5 card. And it comes from the fact that even functions like x squared have y-axis symmetry. Now odd, let's see if you can figure it out. Y equals x cubed. Anybody know what y equals x cubed looks like? We'll get into it in a couple, like next week. Yeah, it does I call it the snake. It snakes on through like that. It goes from low to high. We'll do a bunch of stuff with it next week. With both these. Anyway, what kind of symmetry does that thing have? That's origin. Yeah, not x-axis, huh? It's not the same top and bottom. If it was down here instead of there, then that would be x-axis. That'd be the same top and bottom of the x-axis, but it's not. It's over here. It's 2 quadrants away, isn't it? That's origin symmetry. So odd is another name for origin symmetry. So they're just making up new names for the same old things. There's y-axis symmetry, and they're not going to call it an even function. So it's the same thing. If you say a function is even or a function has y-axis symmetry, you're saying the same thing. Function is odd or function has origin symmetry, you're saying the same thing on that. Yeah?
So if you had a function that had x-axis symmetry, would it be neither?
Oh, no, you can have a couple of these symmetries. Yeah, these are not mutually exclusive. In other words, for example, let me give you one to make sense of what I'm talking about. What if you go to calculus and you have something like that? That thing's got all the symmetries. That's got x-axis, y-axis, and origin. So you can have more than one symmetry. You're not just one necessarily, usually, but not required. You can have a couple of them. Yeah, so just because, so we can't make that other conclusion that if it's not even or not odd, then it's got x-axis or doesn't. It can do all different things. All different things are possible. Good question. This is what's valuable. in this section. Good to spend our time on. Those other ones will be, I think, pretty easy for you. Here's where we need to spend some time. So now they're going to ask me the even, odd, neither thing, and there's no picture. So have you noticed the way this chapter is going? They give us some rules for pictures, and then they strip away the pictures, and we have to fly the plane by the instruments, right? So without any picture, how can you decide just from the equation if the thing is even, odd, or neither? Well, let me give you the rules, and I'll give you reasons for them maybe next week. But here's the rule. So I kind of hate giving things without reasons, but time demands it. So what you do is for the even, odd, neither thing. So for the even, odd thing, you, step one, plug in negative x for x and simplify. No, I wrote that wrong. Simplify. That's not number one. Let me get rid of that one. Just do that first. First, plug in negative x for x, simplify, and then check one. Well, let me say, it's what is it? It's even, so part A, it's even if it's the same as original after simplification. So if it comes out the same as the original after you simplify it, that's an even function. Right, after you plug in the negative x for x and then you simplify, if it comes out the same, that means it's an even function. It's odd if after simplification the new equals -1 times the original. That's odd. Otherwise, if it doesn't fit either one of those conditions, it's neither. Yeah, so that's good. That's the exact same. Good thing to put on your 3x5 card. I've said that a few times now, haven't I?
Yes.
Is there room left? So
Room left on that.
another good thing to put on there is this rules for even and odd. Definitely. This is definitely important to put on there because there'll be a few questions like this on test. It's kind of weird. Probably haven't done it before. All right, so what are we talking about? Let's give it a try with our last 2 minutes here. So if you have f of x equals -5x squared minus 3x. So what I'm saying is just plug in negative x. So good so far. Good to there. Then I simplified. I'm going too quick there. So I plugged in negative x, and I simplified. So this is the new. What's the original? Well, it's up here. Here's the original. Here's the new. After I plugged in negative x and simplified, right? Everybody see what happened there? Negative x squared, that just went away. Because a negative squared is just positive. And 2 negatives made positive there. We good? Mm-hmm. So now the question is the first question, after simplification, is if the, I should say new there, huh? Whatever. I mean, it's if the new is the same as the original. Is it the same? Is this exactly the same as this? No, the plus 3x minus 3x is different. The minus 5x squared is the same, but the back part's different, so it's not even. It's not even. So it's not even. Is it odd? Is if you take the original and you go times negative, if you multiply this by -1, these would both become positive, wouldn't they? Which is not right either. In other words, what we're really asking there is are all the signs opposite? That's what it means to say -1 times the whole thing, right? Are all the signs, is it exactly the same, even? Are all the signs opposite, odd? No, it's really not that either. It's not even, not odd. This one is neither. All right, we're out of time, so we finished, what did we finish? 1-3. We really did finish 1-3. I'm not going to send you any emails, I promise. 1-3 and 2-1 are due on Tuesday. We didn't finish 2-2. We'll do that next week. Have a good week. Got questions? Be glad to answer those.